that kind of completes, our section on the different kind of mixing equipment. And in conclusion, we will just look upon that, we talked about a mixer being made out of several components, and we talked about initially the process design and then the mixing characteristics, and we looked at both of those. And then eventually we will come to the mechanical design of the equipment. So the mechanical design of the equipment includes, making the choice of the motor, deciding the motor horsepower, the type of motor, what is the motor RPM, then the gear reducer, because motors are designed to deliver low torques, okay, and at high speeds, whereas some of the applications may require high torque. That is where we have the gear reducers. So the input speed of the motor is reduced to the desired process speed in a gear reducer, or what is commonly known as gearboxes. There are different kinds of gearboxes, depending on the type of gear construction. What is most commonly used now is helical gearboxes, primarily because these gearboxes work with high efficiencies. The power transmission losses in these are less, rather they work as efficient as 95% and above transmission efficiencies are achievable using helical gearboxes. You have worm gearboxes, which typically give you a transmission efficiency of 70%. You have planetary gearboxes, again, good ability to transmit torques and high speed reductions wherever there is the planetary gearbox is used. It does have limitations on cooling and thermal rating. So you choose a gear reducer based on the operating speeds and several other mechanical parameters. You have couplings which connect the motor to the gearbox. You have couplings which connect the gearbox to the mixer shaft. Again, the choice has to be made depending on the kind of torques that are to be transmitted and the ease of maintenance for these couplings. Mixer seals, you have a rotating shaft, you have a stationary vessel, so you are bound to have seals. There are different kind of mixer seals. Solid mixers have different kind of seals. Liquid mixers have different kind of seals. So in liquid, you have what is commonly known as a design called as a water seal. You have lip seals. You have elastomer seals. You have mechanical seals, and you have stuffing boxes. You have gland packing which seal the vessel contents. In solid mixing, the most common seal is what is called as a gland packing. So typically you have multiple layers of gland packings which are held in place by a gland pusher, and they ensure that the contents of the vessel remain inside the vessel and do not leak to the outside. And same is the case for viscous mixers. So you need to make a choice on the seal depending on the material characteristics. Bearings, again, depending on the types of loads, an equipment may experience axial loads, it may experience radial loads, thrust loads. So depending on that, you make a choice of the bearings. The big advantage that we are now having is that we can operate these mixers over a range of speeds, and that is possible through variable speed operation devices. The most commonly used variable speed operation devices these days are the variable frequency drives. So they are advantageous. They not only help you change the operating speed of the motor, but they also give a soft starting function to the entire drive system. Now, what do we mean by a soft starting function? So when you start a motor, a normal motor would accelerate from 0 to 1400 RPM or 1500 RPM in a fraction of a second. Now, when you have applications which have high torque, viscous mass, this could kind of give a shock load to the system, because you are suddenly starting your system from 0 speed to its maximum operating speed. In such cases, you need to provide a soft start. So VFD gives you the ability where the speed of the motor can be accelerated from 0 to 1440 RPM in whatever duration of time you can decide, typically like say less than 15 seconds. And that allows a slow startup, thereby reducing the maximum demand or the maximum current which will be drawn at the time of startup. There are other devices which also give you variable speed operation. There is what is called as a variable speed fluid coupling. And these are used in extremely large systems. For smaller systems like what we use in mixing applications, the variable speed or the variable frequency drives are the best choice to be made.